Let us look at another example which also deals with rectangular components. A 10-pound block has a speed of 4 feet per second when a force of F equals to 8t squared is applied. We're asked to determine the velocity of the block when t is equal to 2 seconds. The coefficient of kinetic friction at the surface is mu k equals to 0.2. So I'll give you a couple of minutes to solve the problem. Notice here that the force is dependent on time, so it would increase or decrease, which means that the acceleration would also depend on time and it's not constant. But the procedure to solve the problem is exactly the same as before. So for step 1, we need to write down what we know. We have the initial velocity, v0 is equal to 4 feet per second. The force that's being applied at that instant, which is 8t squared, which is variable, and mu k, which is equal to 0.2. We're asked to find the velocity at a specific instant in time, t is equal to 2s. So what can we conclude? First, we're dealing with a 2D system from the image. We know that we're dealing with friction since we're given mu k. We have a variable force which is applied, and from the second law, or Newton's second law, we know that we will have a variable acceleration. We're asked to find the velocity at a specific instant, so we need to find an expression for v as a function of time, and then replace t with the value we want. And so if we want to sketch down the different steps to follow, we have the force, we're given the force. We can calculate the acceleration using the kinetics. And from the acceleration, we can get the velocity using the kinematics. So step 2 now involves drawing the free body diagram. We need to assume a positive sign convention for both axes. So let us have a positive x towards the right and a positive y upwards. Let us now sketch the different forces acting on the block. The block is subject to its own weight, 10 pounds. The reaction force from the ground, which is N. And the force that's applied towards the right, F, is equal to 8t squared. We're also given mu k, so we know that we're dealing with friction. And so friction is always directed in the opposite direction of motion. And since F is being applied towards the right, small f, which is friction, needs to be applied towards the left. And it has a value 0.2 times N. Now step 3 involves drawing the kinetics. So one notices from the given that the block will only move along the horizontal plane. So MAY is equal to 0. So we can only represent a single acceleration component. Since we do not know the direction, or we do not want to assume anything, let us write down the acceleration towards the right, which is the positive sign convention. Now, knowing the two diagrams, we have a better understanding of the forces and the accelerations. We can start solving the equations. We know that we need to start from the kinetics based on what we have concluded from step 1. So we can find A using the equations of motion or the kinetics. So writing down the two equations of motion, since we're dealing with the 2D space, sigma Fy is equal to May is equal to 0, gives us n minus 10 is equal to 0, and so n is equal to 10 pounds. Now we can write down the equation along the x-axis. Sigma Fx is equal to Max. Replacing all the forces along the x-axis, we have the force that's being applied and the frictional force, which is minus 0.2 times 10, the opposite direction, equals to 10 divided by 32.2 times 8. Now I would like to highlight something about the right-hand side. Notice we have divided 10 by 32.2. Some of you might be wondering why are we actually doing that? We're used to just plug in the mass multiplied by the acceleration. Now I want you to notice that whenever you're given weight, that's in pound. So in the given, it's mentioned that the block has 10 pounds. So 10 pounds is the weight. And if you want to write down the equations of motion or Newton's second law correctly, you need to find the mass. And to get the mass in the English system, you need to divide the weight by 32.2. And so that's exactly what we're doing here. 10 divided by 32.2 gives us the mass of the block times the acceleration. So it's just a problem of conversion when dealing with the English units. So having an equation in terms of a and t, we can write a is equal to 3.22 times 8t squared minus 2. So now that we have a, we can find an expression for v using the kinematics, so the equations from chapter 12. A is equal to dv over dt, so we can perform the integration, and we end up with an expression v minus v0 is equal to the integral from t0 to t of the a expression as a function of time. And performing the integration from t0 to t, remember t0 is equal to 0 and v0 is equal to 4, we end up with an expression of v, which is 8.5867 t cubed minus 6.44 t plus 4. And the 4 actually comes from the v0, which we have moved to the right hand side. Now replacing t with 2, we can solve to get the velocity at instant t equals to 2 seconds. And so v is equal to 59.81 feet per second. This problem is no different than the other problems we've solved. The only interesting part here is the fact that the force is variable. And since the force depends on time, we can integrate the expression of a, which also depends on time, to get an expression of v.